So again, integrals find the areas underneath the graph when you take the antiderivative of them. But when you have two graphs like this, you have to find the area of the top graph, the integral of the top graph, and subtract the integral of the bottom graph, and you will get this shaded area. Now the bottom line is just a straight line, which makes the integral easy. And any polynomial, actually, top one is doesn't look like it, but it's a root function. It's a cube root, just expressed as an exponent. And these are quite easy to do. It's when you have sine curves that's hard. So let's look at that. Also note, we have to figure out where they cross, because the graphs, if you look very carefully, don't always say the accurate truth. Where a graph meets are when they are equal. Okay? Fortunately, they gave us the interval 0 to 4, so we don't have to. But you would, if they didn't give you this interval, which would be an extra challenge, you would have to make this graph equal to that one. You subtract the 2 from both sides, and it's essentially when does a cube root of x equal when does a cube root of x equal a third of x, and you would have to solve. Might look hard, but it's actually not. You leave the third here. This is x. You divide x on both sides. This is essentially, the left side is x to the third divided by x is equal to a third. You have to subtract whenever two things have the same base. It's a third minus 1, the exponent here, which is minus 2/3. Minus 2/3 is equal to a third, which is essentially 1 over x to the 2/3 equal a third. You multiply 3 on this side, get on this side. You multiply x 2/3 to get on this side. So it's essentially, when is the cube root of x squared equal to 3? Well, you get rid of the cube root first by cubing it, both sides. Yeah. So when does x squared equal 27? And then when, I probably made a mistake there. So just ignore that, but you would definitely solve it. Let's just let Desmos do it just to show that how you would solve. So the two graphs are x to a third plus 2. It's just a cube root. And a third x plus 2. I think they were both plus 2, not 3. And you can see, oh, look at that. So I was right. They don't, that is the square root of 27. So I did have the right one. But they're just asking us between 0 and 4. So that's interesting, which is fine. So now, be aware that they might not say this, and they might want the whole graph, and you'd have to do that. So how do we do the integral of that? And we don't really need the graph anymore. As I said, it's the top graph, which is the cube root, minus the bottom graph, which is the line. So you have to find the integral of this one. Going from 0 to 4 minus the integral from 0 to 4 of this one. So we have to take the antiderivative. Well, this one's just power of 1. So that means the antiderivative had power of 2. And we just divide it by 2. Essentially dividing by 2 over 1. When we take a fraction divided by a fraction, same as multiplying by the reciprocal. 2 times 3 is 6. So it's really 1 over 6 times x squared. This one was x over 2. You can prove this by taking the derivative, x to the 1 divided by 1. So it's just 2x. And you can prove this when you take the derivative of this, you get 2. When you take the derivative of this, the 2 comes down, cancels into the 6, you get 1/3 x. So that is definitely the derivative of this one. This one is a little harder. We have to add 1 to that, which is 3 over 3. So it becomes 4 over 3. And you have to divide it by 4 over 3, which is the same as multiplying it by the reciprocal. 3 over 4. So that's 3 over 4 times x to the 4 over 3, plus 2x. When you plug 0 into these, they both become 0. So really, you're just finding 4 minus 4 for this. So it's just math at this point. You're taking 3/4 of 4, and that's essentially the cube root of 4 after you put it to the power of 4. So to the power of 4 over 3 means you're taking the cube root and then putting it to the power of 4, plus 2 times 4, which is 8. And this one, you're finding a 6th of x squared, which is 16, plus 2 times 8. Now, we could make our life a little bit easier. And when we're subtracting these things, this minus applies to both, and these 8s would cancel. But we'll just leave it like that. We'll just add this and subtract it. We'll just add this and subtract it. So let's first find 4 to the power of 4 over 3. Which is 6.349. To prove that, in case you're not comfortable with fractions, you'd find 4 to the power of 4. And then you'd find the cube root. And you'd get the same answer. So that's 4 to the power of 4 of 3. And we're going to multiply by 3 and divide it by 4. So that's that. And then we've got to add 8. I'll clear my memory, just add to memory. But this is the number we're working with. Whoops, that's not the number we're working with. This is the number we're working with. And we're subtracting 16 divided by 6 plus 8. And this is the other number we're working with. And we're subtracting it. And you get that. Which means the small volume of that area, since we don't have a measurement, and they don't mention, just a moment, sorry, I got to pause this. So now to prove this, just to make sure we didn't make any math errors, it's always good to use your tools when you're studying. I know people say, well, I won't have the tools, but it actually really helps you to confirm that you did the right integration. And here's what we do. Make one function, the top function. We're going to let Desmos do both the integration, then we're going to test our version of it, and make the other function that. And then we're going to take the integral from 0 to 4 of f of x, the top function, minus g of x, the bottom function. And then you actually have to put that in brackets. And like this. You can skip this part if you want. Times that. And we get the same answer, 2.0953. I'm surprised your teacher didn't want you to round up to a certain thing, but whatever. You can just answer that. Now, Obviously, we've got the right answer as our long form, so it's correct. But just to show you that the I'm going to just work with f of x first. I'm going to call it h of x. That the antiderivative of this is indeed x to the power of 4 over 3 multiplied by the reciprocal. So I can just get rid of that now, which is 3 over 4 plus 2x. And I can prove that's the antiderivative by taking the derivative of it, and I will get the same graph as my original. So that proves the derivative of this is that, which proves that this is indeed the antiderivative. And now I can prove the antiderivative of the other one, which is a little easier because it's just a line. And I can prove that is indeed the antiderivative by taking the derivative of it, and it will indeed match the line. So now that we have the antiderivatives of both, and I'll just get rid of all the other stuff because I really don't need it, I'm just going to prove that h of 4 minus I of 4 is the same answer. There you go. That's how you do that.